The date was March 17th, 1944. Republic Aviation Field, Farmingdale, New York. The morning frost still clung to the tarmac as Master Sergeant Robert Dutch Kellerman stood beneath the massive bulk of a P-47 Thunderbolt, his breath forming small clouds in the cold air. His calloused hands traced the control cables running through the wing root, feeling for the tension that had been wrong for weeks. Every pilot who climbed into these machines complained about the same thing. The controls were too heavy, too sluggish. In a dogfight over Germany, that sluggishness meant death. Dutch knew it, the pilots knew it, but nobody had figured out how to fix it. Until today. Until 17 minutes, that would change everything. If you're fascinated by the untold stories of World War II innovation and the ordinary people who changed the course of aerial combat, make sure to hit that like button and subscribe to our channel. You won't want to miss what happens next. Dutch Kellerman was 32 years old, though the lines around his eyes made him look older. He had joined the Army Air Forces in 1940, back when America was still pretending it might stay out of the war in Europe. He had grown up in Pittsburgh, the son of a steelworker, and had spent his teenage years taking apart and rebuilding anything with an engine. Cars, tractors, even a motorcycle he had found rusting in a junkyard. His father used to joke that Dutch could hear what a machine was thinking just by listening to it run. Now, 4 years into military service, Dutch was one of the most respected mechanics at Republic Aviation, the company that built the P-47 Thunderbolt, the heaviest single-engine fighter plane America had ever produced. Dutch remembered his first day at Republic Aviation with perfect clarity. It had been a gray November morning in 1942, and the factory floor had been a cacophony of riveting guns, grinding wheels, and shouted instructions. Row after row of Thunderbolts in various stages of assembly stretched across the massive building. The scale of the operation had been overwhelming. But what struck Dutch most was the weight of responsibility. Each aircraft rolling off the line would carry a young man into combat. Every bolt he tightened, every system he checked, every adjustment he made could mean the difference between the pilot coming home or not. That weight never left him. It was there in the morning when he arrived at the field, and it was there at night when he finally went home. The relationship between mechanics and pilots at Republic Aviation was unique. Most military installations kept support staff and flight crews relatively separate, but here, testing aircraft fresh from the production line, the barriers broke down quickly. Pilots needed honest assessments from the mechanics who knew the planes intimately. Mechanics needed feedback from the pilots who pushed the aircraft to their limits. Dutch became known for his direct communication style. He did not sugarcoat problems, and pilots appreciated that candor. One pilot, a captain named Michael Reese, had told him, "I would rather know what is actually wrong with my bird than have someone tell me what they think I want to hear." Dutch had nodded and said, "Then you will always get the truth from me, sir." That exchange had set the tone for dozens of relationships that followed. By early 1944, Dutch had worked on more than 200 individual P-47s. He knew the aircraft better than he knew his own car. He could identify specific planes by the sound of their engines, by subtle variations in how they taxied, by the particular way their hydraulics whined during systems checks. But this intimacy with the aircraft also made the control problem more frustrating. He saw how hard the pilots worked to maneuver the Thunderbolt. He watched them climb out of the cockpit after test flights, their flight suits dark with sweat, their arms trembling from the exertion of wrestling the controls. One afternoon in late January, he had been performing a post-flight inspection when Lieutenant Morrison walked past, flexing his right hand and wincing. Dutch had asked if he was all right. Morrison had shrugged and said his hand had cramped up during hard turns. "Just part of flying this beast," he had added. But Dutch had seen the strain in the young pilot's face, and something in him had refused to accept that explanation. The Thunderbolt was a beast. Weighing over 7 tons fully loaded, it was powered by a massive Pratt & Whitney radial engine that could push the aircraft to speeds exceeding 400 miles per hour. It could take incredible punishment, absorb enemy fire that would shred other fighters and still bring its pilot home. But it had one critical weakness. The hydraulic system that controlled the ailerons, the wing surfaces that made the plane roll and turn, was overly complex. The cables ran through pulleys and joints that created friction, resistance. In combat, when a pilot needed to snap into a turn to avoid enemy fire or line up a shot, the P-47 felt like it was fighting him. German Messerschmitt 109s and Focke-Wulf 190s could outturn the Thunderbolt easily. American pilots were dying because of it. Dutch had been obsessing over this problem for 3 months. He had studied the technical manuals until he could recite them from memory. He had watched test pilots ring out the aircraft, noting how they had to muscle the stick, how sweat poured down their faces after just 10 minutes of hard maneuvering. He had spoken with engineers from Republic, men with college degrees and slide rules, but they kept telling him the same thing. The system was already as efficient as it could be. The plane was just heavy. That was the price of durability. Dutch did not accept that answer. He knew machines. He knew that somewhere in that tangle of cables and pulleys, There was wasted energy, wasted motion. He just had to find it. The frustration built slowly over those 3 months. Dutch had always prided himself on his ability to diagnose and fix mechanical problems quickly. But this issue was different. It was not a broken part that could be replaced, or a misadjusted system that could be recalibrated. It was something fundamental about the design itself. The engineers at Republic had created the control system based on sound principles, using proven components and established methods. On paper, everything worked exactly as it should. But Dutch knew that paper and reality were often two different things. He had seen it countless times in his career. A design that looked perfect in a blueprint could have unexpected complications when translated into physical hardware, especially when that hardware had to operate under the extreme conditions of aerial combat. Dutch began keeping a notebook, a small leather-bound journal he carried in his pocket. Every time he worked on a P-47, he made notes about the control system. He measured cable tensions, recorded friction coefficients, sketched the routing of control runs through the airframe. He talked to other mechanics, asking if they had noticed the same issues. Most had, but none had thought much about it. "That is just how Thunderbolts handle," one mechanic had told him. "You get used to it." But Dutch could not get used to it. Every time he signed off on an aircraft and watched it taxi away, he thought about the pilot who would fly it into combat, who would need every advantage to survive. In February, Dutch had requested a meeting with the lead engineer at Republic, a man named Harold Winters, who had been with the company since before the war. Winters was in his 50s, a precise, methodical man who approached every problem with mathematical rigor. Dutch had laid out his observations, explaining the excessive friction in the control system and suggesting that a redesign might improve performance. Winters had listened patiently, then shaken his head. "Sergeant, I appreciate your dedication, but you have to understand the constraints we are working under. The P-47 is already in full production. We are building hundreds of these aircraft every month. A major redesign of the control system would require retooling, retraining, recertification. It would set us back months, maybe longer. And for what? A marginal improvement in handling? The pilots will adapt. They always do." Dutch had left that meeting feeling deflated, but not defeated. Winters was right about the constraints, but wrong about the adaptation. Pilots should not have to compensate for design flaws. The machine should work for them, not against them. The breakthrough came at 2 a.m. on a Tuesday. Dutch had stayed late in the hangar long after the other mechanics had gone home. The overhead lights cast harsh shadows across the skeletal frame of a P-47 that had been partially disassembled for maintenance. Dutch had removed the access panels from the wing root and was following the control cables by hand, his fingers tracing every connection point. That was when he felt it, a subtle vibration in one of the pulleys, a tiny oscillation that should not have been there. He grabbed a flashlight and peered into the narrow space. The pulley was mounted on a bracket that was slightly misaligned, just a few degrees off center. It was a manufacturing tolerance issue, nothing that would show up in a standard inspection, but that misalignment meant the cable was rubbing against the edge of the pulley housing with every movement. Friction, wasted energy, multiplied across dozens of control runs throughout the aircraft. Dutch sat back on his heels, his mind racing. Fixing the pulley alignment would help, but it would not solve the fundamental problem. The system was still too complex, with too many connection points, too many places where friction could build up. What if he could bypass some of those connections entirely? What if he could create a more direct path for the control cables? He grabbed a notepad and started sketching, his pencil moving quickly in the dim light. He drew the existing system, then started removing components, simplifying, streamlining. After an hour, he had something. A modification that would use a simple wire loop to redirect the control cables, cutting out 3 pulleys and 2 connection joints. It would reduce the total cable run by almost 18 inches and eliminate a significant amount of friction. The next morning, Dutch presented his idea to Captain James Hewitt, the engineering liaison officer at the field. Hewitt was a West Point graduate, a by-the-book officer who did not have much patience for improvisation. He looked at Dutch's sketches with a skeptical expression, his jaw working on a piece of gum. "You want to modify the control system of a frontline fighter aircraft with a piece of wire?" he said flatly. Dutch met his gaze steadily. "Not just a piece of wire, sir. A precisely bent and mounted loop that will reduce control resistance by an estimated 20 to 30%. Hewitt shook his head. "This would require approval from Republic, from the engineering division, probably from right field. That could take months." "We do not have months," Dutch said quietly. "We have pilots getting shot down every day because they cannot turn fast enough." Hewitt was silent for a long moment, then sighed. "If you can show me it works, really works, I will push it up the chain. But you get one shot at this, Sergeant, one test flight. If it does not perform, we drop it." Dutch had his chance. He spent the next 6 hours fabricating the wire loop, using high-tensile steel wire that could handle the stress of hard maneuvering. He bent it carefully using a custom jig he built from scrap metal, measuring and remeasuring to ensure the angles were perfect. The loop was simple, elegant, no more than 8 inches of formed wire with reinforced mounting points. But the installation was delicate work. He had to remove sections of the existing cable runs, reroute them through the new loop, and ensure the tension was exactly right. Too loose, and the controls would be sloppy. Too tight, and they would bind up. By 3 in the afternoon, he was done. The modification had taken him 17 minutes to install once all the preparation was complete. Dutch had chosen the wire carefully. It was the same high-tensile steel used in aircraft control cables, rated for loads far exceeding what the aileron system would ever experience. He did not want there to be any question about the structural integrity of his modification. The jig he built was a simple wooden frame with precisely positioned pins that held the wire in place while he made the bends. Each angle had to be exact. A deviation of even a few degrees would affect the cable routing and potentially create new friction points. He worked slowly, methodically, checking each dimension 3 times before committing to a bend. His hands were steady, but his mind was racing. If this worked, it could change everything. If it failed, he would have wasted Captain Hewitt's one opportunity and proven the engineers right. The installation required him to partially disassemble the wing root access panel and disconnect several control cable sections. Other mechanics gathered around, watching with a mixture of curiosity and skepticism. One of them, a corporal named Jimmy Diaz, asked if Dutch was sure he knew what he was doing. Dutch had looked up from his work and said, "No, but I am going to do it anyway." That honesty had earned him a nervous laugh from the watching mechanics. They knew the pressure he was under. If something went wrong during the test flight, if the modification caused a control failure, it would not just be the end of Dutch's idea. It could be the end of Dutch's career, possibly even lead to a court-martial if the failure resulted in damage to the aircraft or injury to the pilot. As Dutch worked, he explained what he was doing to the mechanics watching. He wanted them to understand the principle behind the modification so they could replicate it if the test was successful. He showed them how the new loop created a more direct cable path, how it eliminated the 3 problematic pulleys that had been causing the most friction. He demonstrated how the mounting points distributed the load evenly, preventing stress concentrations that could lead to fatigue failures. By the time he was finished, the mechanics understood not just what he had done, but why he had done it. That knowledge would prove crucial in the weeks to come when the modification needed to be implemented across hundreds of aircraft. The test pilot was Lieutenant Frank Morrison, a 24-year-old from Oregon who had flown combat missions over France. Morrison had a reputation for being brutally honest in his assessments. If something was wrong with an aircraft, he would say so, loudly, and in terms that left no room for misinterpretation. He walked around the P-47, inspecting Dutch's work with a critical eye. "This is going to make a difference?" he asked. Dutch nodded. "It should make the ailerons significantly more responsive, sir." Morrison grunted. "Let's find out." He climbed into the cockpit, strapped in, and fired up the massive radial engine. The propeller blades bit into the cold March air, and the Thunderbolt rolled toward the runway. Dutch watched as Morrison completed his pre-flight checks, the sound of the 18-cylinder radial engine echoing across the field. The vibration from that massive power plant could be felt through the ground, a deep rumbling that Dutch had come to associate with power and reliability. But today, all he could think about was the small wire loop hidden in the wing root, the 17 minutes of work that represented 3 months of obsession. Captain Hewitt stood beside him, arms crossed, expression unreadable. Other mechanics had gathered as well, forming a small crowd near the hangar. Word had spread that Dutch was testing a modification, and everyone wanted to see if it would work or if it would be another failed attempt at improving an already proven design. Morrison released the brakes, and the Thunderbolt began its takeoff roll. The big fighter accelerated smoothly down the runway, its tail coming up as it gained speed. At about 90 miles per hour, Morrison eased back on the stick, and the aircraft lifted off, climbing steeply into the clear March sky. Dutch shielded his eyes against the sun, tracking the aircraft as it climbed to 5,000 feet. His heart was pounding. Everything he had worked for, everything he believed about his ability to solve mechanical problems, was riding on the next 20 minutes. If Morrison came back and said the modification made no difference, or worse, that it had made the controls worse, Dutch would have to accept that maybe the engineers were right. Maybe some problems could not be solved by a mechanic with a good ear and steady hands. Morrison began his evaluation runs at 5,000 feet, far enough up to provide a safety margin, but low enough that Dutch and the others could still see the aircraft clearly. The Thunderbolt rolled left, then right, the wings snapping through the maneuvers faster than Dutch had ever seen. Morrison pulled into a hard climbing turn, the fighter arcing through the sky with what looked like effortless grace. Then came the real test, a series of defensive maneuvers that simulated evading an enemy fighter. The P-47 jinked and rolled, changing direction rapidly, pulling tight turns that would normally have been at the outer edge of what the aircraft could handle. Dutch felt his breath catch. The plane was responding. It was actually responding the way he had hoped it would. After 15 minutes of increasingly aggressive maneuvers, Morrison set up for a series of mock gunnery runs, diving on an imaginary target and pulling up hard, rolling to reacquire the target, then diving again. Each maneuver was sharp, precise, controlled. Dutch had watched enough test flights to know what he was seeing. When the P-47 was not fighting Morrison anymore, the controls were working with him, translating his inputs directly into aircraft motion without the sluggish delay that had characterized every Thunderbolt Dutch had ever seen fly. When Morrison finally brought the aircraft back down, Dutch felt a wave of relief so intense it almost made his knees buckle. Captain Hewitt glanced at him and said quietly, "That looked different." Dutch could only nod, not trusting himself to speak. Dutch stood with Captain Hewitt and a handful of other mechanics, watching as the P-47 accelerated down the runway and lifted off. Morrison climbed to 5,000 feet, then began putting the aircraft through its paces. Barrel rolls, tight turns, snap reversals. From the ground, Dutch could see the difference immediately. The plane was moving crisper, responding faster to control inputs. After 20 minutes, Morrison brought the Thunderbolt back down, landing smoothly and taxiing back to the apron. He shut down the engine and climbed out, his face unreadable. Dutch felt his stomach tighten. Then Morrison broke into a wide grin. "That is the best this bird has ever handled," he said. "It is like flying a completely different airplane. I could feel the difference the moment I touched the stick. Whatever you did, Sergeant, it works." Morrison walked directly to Dutch, pulling off his leather flight gloves as he approached. He extended his hand and Dutch shook it, still processing what he had just heard. Morrison's grip was firm, his eyes intense. "I have been flying P-47s for 8 months," Morrison said, "and I have never felt controls that responsive. I took her through every maneuver I could think of. Defensive scissors, barrel rolls, maximum rate turns. She responded instantly, no lag, no mushiness. I could hold a tighter turn radius by at least 10 degrees, maybe more. In a dogfight, that is the difference between getting a shot off or getting shot." Captain Hewitt had walked over, his expression still skeptical but interested. "How much better are we talking, Lieutenant?" Morrison did not hesitate. 30% improvement, maybe more. The ailerons are night and day. If we could get this modification on every P-47 heading to Europe, we would save lives, a lot of lives. The small crowd of mechanics erupted in excited conversation. They had all seen the flight, had all noticed the improved performance, but hearing Morrison quantify it made it real. Dutch felt hands clapping his back, heard congratulations being offered, but his focus was on Captain Hewitt. The officer was studying Morrison's face, clearly weighing the pilot's enthusiasm against his own natural caution. Finally, Hewitt turned to Dutch. "Get me a full technical write-up by tomorrow morning," he said. "Include material specifications, installation procedures, time requirements, and projected durability. I want load calculations and failure analysis. If I am going to send this up the chain, I need to be able to answer every question they are going to throw at me." Dutch nodded. "Yes, sir, I will have it ready." Hewitt's expression softened slightly. "Good work, Sergeant. Now let us hope the brass sees it the same way Morrison does." Dutch spent that entire evening and most of the night preparing the documentation. He worked at a small desk in the corner of the hangar, surrounded by technical manuals, engineering references, and his own notes. He drew detailed diagrams showing the modification from multiple angles, including dimensions and tolerances. He wrote out step-by-step installation instructions that any competent mechanic could follow. He calculated the load-bearing capacity of the wire loop under various stress conditions, showing comfortable safety margins, even under extreme maneuvers. He projected that installation would take between 15 and 20 minutes per aircraft, meaning a small team could modify dozens of fighters in a single day without significantly impacting operational readiness. By dawn, he had produced a 20-page technical document that he believed would answer any question the approval authorities might have. Captain Hewitt looked at Dutch, then at the aircraft, then back at Dutch. "Get me a full technical write-up by tomorrow morning," he said quietly. "I'm sending this to Wright Field with a priority recommendation." Within a week, Dutch's modification was being tested at the Army Air Force's Materiel Command Headquarters in Ohio. Within 2 weeks, it was approved for field implementation. Within a month, mechanics at air bases across England were installing the modification on every P-47 in the European theater of operations. The simple wire loop that Dutch Kellerman had designed in a cold hangar on Long Island was now standard equipment on one of America's most important fighter aircraft. The approval process moved with unprecedented speed, driven by Morrison's enthusiastic endorsement and Captain Hewitt's detailed technical submission. At Wright Field, test pilots put a modified P-47 through the most demanding evaluation protocol the Army Air Forces had. They flew the aircraft to its performance limits, testing control response at high speeds, low speeds, in climbs and dives during high G turns. They subjected the modification to stress analysis, examining the wire loop for signs of fatigue or deformation. They compared the modified aircraft against standard P-47s in simulated combat scenarios. Every test confirmed what Morrison had reported. The modification worked exactly as advertised, improving aileron response by approximately 30%, with no negative effects on any other aircraft system. The formal approval came in the form of a technical directive issued on April 2, 1944. The directive authorized field modification of all P-47 aircraft and mandated that the modification be incorporated into new production aircraft coming off the Republic Aviation assembly line. The directive included Dutch's installation instructions, slightly edited by engineers at Wright Field, but otherwise unchanged. It specified that the modification should be prioritized for aircraft assigned to fighter groups in the European theater, where air superiority missions required maximum maneuverability. Within days, mechanics at bases across England were receiving shipments of the pre-fabricated wire loops, along with detailed installation kits and Dutch's instructions. The implementation was not without challenges. Some mechanics, particularly older veterans set in their ways, were skeptical about modifying a proven aircraft design based on a sergeant's idea. Dutch received several phone calls from base maintenance officers asking for clarification or expressing concern about warranty implications. He patiently explained the modification's benefits, walking them through the installation process step by step. In some cases, he flew to bases to personally demonstrate the installation and answer questions. His credibility as a fellow mechanic, someone who had actually designed and tested the modification, helped overcome much of the resistance. Mechanics trusted other mechanics more than they trusted engineers in distant offices. By late April, over 600 P-47s in England had been modified. Pilot reports began flooding back to command headquarters. The improved handling was making a real difference in combat. Fighter groups reported increased success rates in engagements with German aircraft. Pilots, who had previously avoided turning fights with Messerschmitts and Focke-Wulfs, were now willing to engage, confident that their aircraft could keep up. Loss rates in fighter versus fighter combat began to decline noticeably. The 8th Air Force commander, General James Doolittle, personally sent a commendation to Republic Aviation, praising the rapid implementation of a field modification that had materially improved combat effectiveness. The commendation specifically mentioned Dutch Kellerman by name. The impact was immediate and measurable. Pilots reported that the P-47 could now hold its own in turning fights with German fighters. The improved aileron response allowed them to roll faster, reverse direction more quickly, and maintain control in high-stress combat situations. Loss rates began to drop. Kill ratios began to improve. The Thunderbolt, already respected for its toughness, now had the agility to match. Letters started coming back from Europe, from pilots who had survived engagements they might not have lived through before. One letter, addressed directly to Dutch, came from a pilot named Charles Anderson. He wrote that he had been jumped by 2 Focke-Wulf 190s over Belgium and had managed to outmaneuver them long enough for his wingman to intervene. "I do not know who came up with the mod to these controls," Anderson wrote, "but they saved my life yesterday. Tell them thank you." That letter was the first of many. Over the following months, Dutch received dozens of letters from pilots in Europe. Some were brief, just a few lines thanking him for the modification. Others were longer, describing specific combat engagements where the improved controls had made the difference. A pilot named David Goldman wrote about a dogfight over Frankfurt where he had been able to stay with a Messerschmitt 109 through a series of rolling scissors maneuvers, eventually getting a deflection shot that sent the German fighter down in flames. "Before your mod," Goldman wrote, "I would have had to disengage and run, but I could match him turn for turn, and that is what saved me." Another pilot, Richard Hayes, described escorting B-17 bombers deep into Germany and being attacked by a formation of enemy fighters. The ability to quickly snap into defensive positions, Hayes wrote, allowed our group to break up their attack before they could get to the bombers. "We did not lose a single bomber that day, and I credit the improved handling of our birds." Dutch kept every letter in a wooden box he had built himself. He did not show them to many people, but he would take them out occasionally and read them when he was alone. Each letter represented a life, a young man who had gone into combat and come back alive. The letters reminded him why he had spent those long nights in the hangar, why he had refused to accept the engineers' dismissals, why he had pushed so hard to solve a problem that everyone else had accepted as unsolvable. The weight of responsibility that he had felt since his first day at Republic Aviation had not diminished, but now it was balanced by something else. The knowledge that his work had made a tangible difference, that the 17 minutes he had spent installing that wire loop had rippled out across the Atlantic, affecting thousands of pilots and altering the course of countless air battles. One letter stood out among all the others. It came from a pilot named William Preston, who flew with the 56th Fighter Group out of England. Preston wrote that he had been shot down over Germany in May 1944, bailing out of his damaged P-47 and spending 3 months evading capture before finally making it back to Allied lines. The reason he had survived long enough to bail out, Preston explained, was that the improved control response had allowed him to avoid taking critical damage during the initial attack. "I took hits in the engine and fuselage," Preston wrote, "but I was able to maneuver aggressively enough that the German pilot could not get a solid firing solution on my cockpit or fuel tanks. That gave me time to gain altitude and bail out over friendly territory. If the controls had been as sluggish as they were before your modification, I would not have been able to evade effectively. I would have taken more hits, probably fatal ones. Instead, I am alive, and I owe that to you." Dutch read that letter 3 times the day it arrived, and each time he felt his eyes sting with emotion, he rarely allowed himself to show. Dutch kept that letter in his toolbox for the rest of the war. He did not talk much about his role in the modification. When other mechanics asked him about it, he would shrug and say he had just been doing his job, but those who worked closely with him knew better. They had seen the long nights, the relentless focus, the refusal to accept that a problem could not be solved. Dutch represented something essential about the war effort, something that went beyond the generals and the politicians and the grand strategies. He represented the thousands of ordinary people who saw a problem, refused to walk away from it, and found a solution through sheer determination and skill. The modification became known informally as the Kellerman Loop, though it was never officially designated as such in military documentation. Republic Aviation incorporated the design into later production runs of the P-47, and the principle behind it influenced control system designs in other aircraft. After the war, Dutch returned to Pittsburgh and opened a small garage, working on cars and trucks. He rarely spoke about his time in the military. When people asked, he would say he had been a mechanic, nothing special. But on the wall of his office, in a simple frame, hung a photograph of a P-47 Thunderbolt in flight, and next to it, a letter from a pilot he had never met, thanking him for 17 minutes of work that had made all the difference. The story of Dutch Kellerman and his wire loop is a reminder that innovation does not always come from laboratories or engineering departments. Sometimes it comes from a mechanic standing in a cold hangar at 2 a.m, running his fingers along a cable and feeling something that is not quite right. It comes from someone who refuses to accept that a problem is unsolvable, who trusts their instincts and their experience, and who has the courage to try something new even when everyone else says it cannot be done. The P-47 Thunderbolt became one of the most successful fighter aircraft of World War II, flying more missions and destroying more enemy aircraft than almost any other American fighter. And at the heart of its success was a simple piece of wire, bent and mounted by a sergeant from Pittsburgh who knew how to listen to what a machine was telling him. By the summer of 1944, Dutch's modification had been installed on over 4,000 P-47s operating in Europe and the Pacific. The 8th Air Force, flying out of England, used Thunderbolts extensively as both fighter escorts for heavy bombers and ground attack aircraft. Pilots like Francis Cabreski and Robert Johnson became aces flying P-47s, racking up dozens of confirmed victories. They flew aircraft that handled better, responded faster, and gave them the edge they needed in combat. Not all of them knew about the Kellerman Loop, but every one of them benefited from it. That was how Dutch wanted it. He was not interested in recognition or fame. He was interested in solving problems and keeping people alive. In September 1944, Dutch was promoted to technical sergeant and reassigned to a training facility in Texas, where he taught other mechanics advanced troubleshooting and modification techniques. He emphasized the importance of understanding not just how a system was supposed to work, but how it actually worked in practice. He told his students to trust their hands, to feel for the things that technical manuals could not describe, to never assume that something could not be improved just because someone with more education said so. Some of his students went on to become influential figures in post-war aviation, bringing his philosophy with them into the jet age. The training facility was located outside San Antonio, a sprawling complex of classrooms, hangars, and maintenance shops, where the Army Air Forces prepared mechanics for deployment overseas. Dutch had initially resisted the reassignment. He wanted to stay at Republic Aviation to continue working directly on the P-47s that were going into combat. But Captain Hewitt had convinced him that he could have a greater impact by training the next generation of mechanics. Your modification saved lives, Hewitt had told him, but your knowledge could save even more. Teach these men how to think the way you think, how to see problems the way you see them, and multiply your impact 100-fold. Dutch's classes were unlike any other mechanical training the students had received. He did not simply lecture from technical manuals or demonstrate procedures by rote. Instead, he brought broken or malfunctioning components into the classroom and challenged the students to diagnose the problems without referring to documentation. He would hand a student a length of control cable with a subtle kink in it and ask them to feel the difference between that cable and a perfect one. He would play recordings of engines running and ask the students to identify which cylinder was misfiring based solely on sound. He taught them to use all their senses, to treat mechanical diagnosis as a craft that required intuition and experience as much as technical knowledge. One of his favorite teaching exercises involved taking students into the maintenance hangar late at night, after the regular work shifts had ended. He would walk them through rows of parked aircraft, pointing out small details that most mechanics would miss. A slight irregularity in how a propeller blade caught the light, indicating a stress crack. A faint smell of leaking hydraulic fluid from a connection that appeared tight. The particular sound a gear made when a bearing was beginning to wear out. These are the things that will keep you alive, and keep the pilots you work for alive, he would tell them. Anyone can follow a manual. I'm teaching you to understand the machines you work on, to listen to what they are telling you. His most impactful lesson was about persistence and problem solving. He would describe his own experience with the P-47 control system, the 3 months of frustration, the resistance from engineers, the skepticism from officers. He explained how he had refused to accept that the problem was unsolvable, how he had kept searching for the root cause even when everyone told him he was wasting his time. The breakthrough does not come from being smarter than everyone else, he would say. It comes from being more stubborn, more willing to keep looking when others have given up. When you find a problem that matters, that affects people's lives, you do not walk away from it, you stay with it until you find the answer. The war in Europe ended in May 1945, and the war in the Pacific ended in August. Dutch was discharged in November and returned to civilian life. He married a woman named Eleanor, a nurse he had met during his training assignment in Texas. They had 3 children and lived quietly in Pittsburgh for the next 4 decades. Dutch worked in his garage, building a reputation as someone who could fix anything. People brought him cars that other mechanics had given up on, and he would spend hours tracing wires, testing circuits, listening to engines until he found the problem. He approached every job with the same methodical patience he had brought to that P-47 in 1944. Eleanor used to joke that he talked to machines better than he talked to people. Dutch would smile and say that machines were honest. They told you what was wrong if you knew how to listen. In 1987, Dutch received a letter from the Smithsonian National Air and Space Museum. They were preparing an exhibit on the P-47 Thunderbolt and had learned about his contribution to the aircraft's control system. They wanted to interview him, to include his story in the exhibit. Dutch was reluctant at first. He had never considered himself a hero, just a mechanic who had done his job. But Eleanor convinced him to do it. You helped save lives, she told him. People should know that. Dutch agreed to the interview. He spent an afternoon talking with a historian, describing the process of identifying the problem, designing the solution, and testing the modification. The historian asked him if he had been nervous, knowing that a pilot's life would depend on his work. Dutch thought about it for a moment, then said, "I was more nervous about not trying. If I had walked away from that problem, if I had just accepted what everyone else was telling me, pilots would have kept dying. That would have been worse than any nervousness I felt." The exhibit opened in 1988, and Dutch traveled to Washington with Eleanor to see it. There was a full-size P-47 hanging from the ceiling, its massive bulk suspended by cables, and on the wall next to it was a display about the various modifications and improvements that had been made to the aircraft during the war. Dutch's wire loop was mentioned, along with a photograph of him from 1944, young and serious, standing next to a Thunderbolt. He stood there for a long time, looking at the plane, remembering the cold mornings at Republic Aviation, the smell of hydraulic fluid and engine oil, the sound of radial engines firing up at dawn. A young boy, maybe 10 years old, came up beside him and read the display. He turned to Dutch and asked, "Were you really the guy who made that thing fly better?" Dutch nodded. "I helped a little," he said. The boy looked at him with wide eyes. "That is so cool," he said. Dutch smiled. "It was just 17 minutes of work," he said, "but they were an important 17 minutes." Dutch Kellerman passed away in 1993 at the age of 81. His funeral was attended by family, friends, and a surprising number of people he had never met. Veterans who had flown P-47s during the war, engineers who had studied his modification, mechanics who had learned from his example. One man, a former pilot named Thomas Chen, stood up during the service and told a story. He had been flying a mission over Germany in late 1944 when his squadron was bounced by enemy fighters. He had managed to evade and survive because his P-47 had responded exactly when he needed it to. Years later, he learned about the Kellerman loop and realized that the modification had been the reason he made it home that day. "I never got to thank him personally," Chen said, his voice thick with emotion. "So I am thanking him now. He saved my life, and he probably saved hundreds of others. That is a legacy that matters." The story of Dutch Kellerman and his 17-minute modification is more than just a technical footnote in the history of World War II aviation. It is a story about the power of practical knowledge, about the importance of listening to the people who work directly with technology rather than just the people who design it. It is a story about persistence, about refusing to accept limitations, about trusting your instincts even when everyone else is skeptical. And it is a story about the countless ordinary people whose contributions made victory possible, the mechanics and technicians and support staff who kept the machines running, who solved the problems that no one else had time to solve, who made the critical difference between success and failure, between life and death. Dutch Kellerman never flew a combat mission. He never fired a shot in anger. But his 17 minutes of work in a cold hangar in New York changed the course of the air war over Europe and saved lives in ways that can never be fully calculated. That is the kind of quiet heroism that defines the best of what people can achieve when they dedicate themselves to solving problems and helping others. That is a legacy worth remembering.